Now our next couple of examples will give us practice determining the domain and range of a relation given its graph. So in our first example, we have the graph of a line segment, which you can see is graphed below here in blue. And the two dots indicate that the graph stops at those 2 points. Now, before we go any further, might be good just to do a quick refresher here. I trust that you recognize that this is the graph of a function because it passes the vertical line test. And you remember that says if a vertical line can intersect the graph in more than one place, it's not a function, and that's not possible in this case, so we have the graph of a function. Now, before we determine the domain and the range, I think it might be helpful here if we were to state the coordinates of the endpoints of the segment. And the right-hand endpoint here has the coordinates 6, 4. And the left-hand endpoint has the coordinates -6 and -2. Now, to determine the domain, we can think of that in a sense as being the horizontal extent to the graph. In other words, how far left and how far right does it go? And that will be determined by the x values of points on the graph. So we can see that the smallest x value for any point in the graph is at the left-hand endpoint, which is -6. And the largest x value is the x coordinate of the right-hand endpoint, which is 6. So we could then say that the domain, if we express this in interval notation, would be then -6 to 6. And we enclose those values in brackets because both of the endpoints are included in the graph. Now we might also want to review set builder notation for this. So if I want to express the domain using set builder notation, we would say the set of all x such that -6 is less than or equal to x, which is less than or equal to then +6. Now, to determine the range, we can think of that as being the vertical extent to the graph, if you will. How far up and how far down does it go? In this case, we can see that the smallest y value is -2, which is the y coordinate of the left-hand endpoint. And the largest y value is 4, which is the y coordinate of the right-hand endpoint. So we could say then that the range is -2 to 4. And again, we enclose those values in brackets because the endpoints are included in the graph. And if we wanted to represent this using set builder notation, we would write the set of all y such that then -2 is less than or equal to y, which is then less than or equal to 4. And there we have it. Now in our next example, we're going to consider finding the domain and range for a line. And in the other example we just looked at, you remember that was a line segment that had a definite endpoint on the left and the right. Now the arrows here indicate that the line continues indefinitely to the right and then to the left. Now if we think about the domain, remember that means what the horizontal extent is to the graph. So how far left and how far right can it go? And you can see it will go as far left and as far right as we would like it to go eventually. So it will take on all real values. So we would say the domain, if we write this in interval notation, would be -infinity to infinity. And for the range would be the vertical extent to the graph. So how far up and how far down might it go? Well, eventually it'll go as high as we would like, and it will go as low as we would like. So we'll take on all real values. So the range then we could express also in interval notation by writing -infinity to infinity. So for both the domain and the range, both would be then the set of real numbers.